Now we're looking at section 2.1. So in section 2.1, we're going to be looking at qualitative or categorical data. And we're going to look at how we can organize it in tables. We're going to construct some bar graphs and pie graphs, and this will, so we're going to do some bar graphs and pie graphs and look at qualitative data and how to organize it. So this is just the very beginning of the foundation of everything we're going to be learning this term. So once again, hopefully you have your notes available, and let's go. So as a reminder, qualitative or categorical data is looking at things that are generally not numerical, and if they're numerical, then it's not numbers that you would do math with. This is things that look at like characteristics like right-handed, left-handed, color of hair, what color car you drive, things like that. So these are things that are mostly, it's usually words or categories. So next we have frequency distribution. Frequency distribution, basically it's exactly what it sounds like. It tells how frequently a number shows up in your data. So when we have our raw data is just everything unorganized, just as you're counting them. Like if I was counting the color of cars driving by, it would just be like blue, gray, red, blue, black. So it's just listing it all out. It's just completely raw. You haven't cooked it yet. So it is just completely raw data. So when we take all of that and then we categorize it, we put it all together and say, okay, there are, how many blue cars were there? There were 5. How many red cars were there? There were 3. So when we say how frequently each color shows up, that would be your frequency distribution. I'll show you what that looks like in a minute. So once again, I just mentioned what the raw data was. See, I frequently do that. Say it before it shows up. So before we cook it, before we do anything with the data, that is just the raw data. We have this big old pile of data. We haven't organized it yet. It doesn't look pretty yet. It is just basically as we got it, we just wrote it down. That is your raw data. So here's the ways that we can organize our data. We've already looked at a numerical summary in our chapter 1 stuff, but we can also use tables or graphs. Let's see what that looks like. So on the next slide, we have our color of M&Ms. So we took a bag of M&Ms and we just took the M&Ms out, and when we pulled each M&M out, we wrote down what color it was. So we got this big old pile of raw data. So there's our big pile of raw data. See, nothing's been done with it yet. It's completely disorganized. It is what it is. It's just as we pulled the M&Ms out of the bag, this is what we got. So let's organize it in a frequency distribution. So here is a frequency table. So on the left column, so right here on the left column, I just listed out all of the colors that I had in the bag of M&Ms. You don't have to show the tally marks in your frequency tables. This is just as I was counting them, I cross them out and put tally marks with each one I see. And so this right here is the frequency. How frequently did it show up? Brown showed up 12 times. Yellow showed up 10 times. Red showed up 9 times, etc. This is your frequency table. So one thing I want to add to this is cumulative frequency. Oh, I'll do that. Sorry, we will do that when we get to relative frequency. So hold that thought. So we will, sorry about this. Okay. We will look at that in a minute. So this is just a basic frequency table. It shows how often each number shows up. And sometimes we just display it like this. And sometimes we will take it and organize it in a table or a histogram, in a pie chart or a histogram or something like that. So let's take a look. Relative frequency. So relative frequency shows me the proportion or percent of observations that shows up. So it'll tell me what percent of the candies were brown, what percent or proportion of the candies were blue. So we write these sometimes as fractions, sometimes we write them as decimals, and sometimes we write them as percents. So you need to be able to convert from fraction to decimal to percent. So with relative frequency, we take the frequency that value showed up, so how many candies were brown, over the sum of all frequency, or the total number of items. So how many candies were there? There were a total number of this many candies, and here's how many of them were brown. That will give us a fraction. So if you're giving me a relative frequency as a fraction, make sure you simplify it. Most of the time, though, we're going to want that as a decimal or a percent. So a relative frequency distribution, that is a table that shows the relative frequency of each item. So let me move on and show you what that looks like. So once again, here's our frequency table from our candies. And I have a total of 45 candies. So I took the 12, the number of brown candies, and I divided it by the total number of candies. And I got 0.2667, or 26.7, about 26.7% of my candies were brown. And then I did 10 divided by 45, and I have 22.2% of my candies were yellow. And then 9 divided by 45, 6 divided by 45, etc. So when we do this, it is easier to compare bags of candy. So let's say that you also had a bag of M&Ms, but you would have a different number of M&Ms in your bag, because clearly they're not going to be consistent with the number of M&Ms in the bag. So you would have a different number. So you saying you have 12 doesn't make very much sense. So if you also had 12 brown candies, if you had 53 candies in your bag, comparing the number of brown candies in each bag doesn't make a whole lot of sense. So we will use relative frequency so that we are comparing kind of the same, it's kind of like comparing the same unit. So we're making it all into percents or proportions. So you would be able to say, so if you had 53 candies in your bag, you would do 12 divided by 53. So the proportion of candies that you had that are brown would be 22.6%, or 0.2264. So it would be easier to compare. So it would be a lot easier to compare that rather than comparing 12 brown candies to 12 brown candies. Hopefully that makes sense. So we like to use relative frequency because it gives us a better idea of how many brown candies there are compared to other colors. So this is relative frequency, and this is frequency. So let's take a look at bar graphs. So you've seen bar graphs like all over the place. You see them probably every day, or pretty close to every day. And you've probably even made a bar graph or two in your life. So with a bar graph, what we do is we label each category. Usually we label them on the horizontal axis, though sometimes we like them sideways. So you will label those on the horizontal axis or vertical. And then the other axis will be the frequency or relative frequency. And make sure that you're putting the word frequency there. So we make rectangles of equal width. We draw them for each category. And then the height represents either the frequency or the relative frequency. I will show you what that looks like with the M&Ms in a second. So we're going to construct a frequency bar graph and a relative frequency bar graph. So here's my frequency table from my M&Ms. And here is my bar graph. So make sure you are labeling and you're putting tick marks. Frequently will say title, tick, tick, label, label, label. So we have our title, our ticks, label, label, label. I know that's really ugly. Let me get rid of that. So I have my title for my bar graph. We don't know what we're looking at unless you have a title. You will be marked down on labs and hand-drawn graphs if you don't have a title. And then these right here, these labels here, tell me what each axis is. So the horizontal axis is the color. And I know it's about M&Ms because I have this title up here, so I don't have to necessarily say color of M&Ms, but I could if I wanted to. So color down here, and then I need to list out the colors so I know what each bar represents. I know this one's brown, yellow, red, etc. And then frequency. So I need to know what I'm looking at on the left side. What is that? It is the frequency. So it is based on our frequency table. So this says this is how frequently it shows up. I mean, technically, if you wrote the word count, it would be okay. But the standard term that we use in stats would just be frequency. So using that word is probably a good idea. So use frequency. And make sure you have labeled consistently along the side. This one is going up by 2, and it needs to start at 0. And then I drew each bar up to how many it is. These in a bar graph, the bars do not touch each other. They're about the same width. They're nice, pretty rectangles. So let's take a look at a relative frequency bar graph. It's going to look almost identical. Here's my relative frequency table. Here is my relative frequency bar graph. It looks almost identical. The difference is on my vertical axis, or my y-axis here, my tick marks over here are going up by the proportions. So it starts at 0. Look, I'm going up by basically 5%. So I have 5%, 10%, 15%. Figure out what your highest percent is. Ours was 26.67 or 0.2667. So my top is 3. Make sure you make that, or 30% or 0.3. Make sure you make that top just like right above whatever your highest one is, unless you really like to go up to 0.5. Just make sure that you're paying attention to where that top one is. You don't need it to go to 100% because nothing's going to be even close to that 100%. Make sure you label the axis here as relative frequency because that's what it is. This is the relative frequency. All right, let us move on. A Pareto chart, we don't use this a whole lot. Sometimes we use it and it can only be used in categorical. Sometimes we use this just to kind of make it prettier. So we just are organizing the colors or the bars so that they're going from highest to lowest. So see, I just reorganized it so that that it went in order from highest to lowest. So you have your like stair steps down. So it is just really just visually to make it pretty. And so you can see which is the highest and which is the lowest. This is called a Pareto. And I don't actually even think that it shows up in your homework. I can't remember it showing up. If it does, then it just means that nobody's ever asked me a question about it. So I kind of have overlooked it. So this is a Pareto chart. Okay, so now let's take a look at some different data that we're going to compare here. So this is marital status in millions of U.S. residents from 18 years and older between 1990 and 2006. So we're going to draw a side-by-side chart. This is something you've probably seen in the news and other places over and over and over again. So in 1990, 40.4% of people were never married. Oh no, this is data in millions. This is not sorry about that. This is not relative frequency. 40.4 million people were never married. And in 2006, 55.3 million people were never married. And look at these different things here. We are not comparing. We're not comparing relative frequency. This is a frequency table. This is not relative frequency. We need to create that relative frequency. So I'm going to do that on the next page. Remember, to calculate relative frequency, we would add all of them together, so get our total, and then we would put this value, each value, over that total. So let's see what that looks like. Oh, I have my relative frequency here on the y-axis. I say marital status here on the bottom. And I probably, maybe somewhere in whatever the write-up is of this, it says that it's in the U.S., because is this in the U.S.? Yeah. But if it doesn't, then you would need to have a little bit more marital status in of U.S., I would say of U.S. residents. Maybe put that. Um, or maybe there's a little write-up about this, a whole story surrounding it. So this right here now shows our comparison of each, and this is relative frequency. So we're comparing apples to apples. We're comparing like terms, so to speak. Make sure that your label here says relative frequency so we know what we're looking at. Make sure that you have your labels here so we know what we're looking at. My colors over here give me a key, so I know which color represents which, and it is nice and pretty, and we can do whatever we need to do to make whatever inferences we make. We can say that fewer people are getting married in 2006, more people are never married, whatever you want to say. Whatever you want to say, whatever you're trying to look at, looking at divorce rates are higher, whatever. Whatever you're going to use this data for. All right, let's look at some pie charts. So you've probably seen pie charts over and over again. None of the stuff in this lesson is super new. I think maybe just a little bit of new vocabulary, but it's all stuff that everybody sees on kind of on a day-to-day basis. Or if you watch the news, you see it really frequently. So pie charts, we've divided it into different sectors. Each sector represents a category, and the area of the sector is proportional to the frequency. So if I would say something was 50%, so you know that a circle has 360 degrees, so 180 of those degrees would be whatever that category is. So let's take a look with the 2006 data of people married, the marital status. So I just took this frequency here, and I'm going to put it into a nice pretty pie chart. Usually when I'm making a pie chart, I will make sure that the percents show on the pie chart, because it doesn't make as much sense if you can't see those percents on there. When you're doing it in Excel, when you're making them in Excel, you have to specifically click on, I'll show you when we're doing the lab, you have to specifically click on things to make sure that the percents show up. You can make a pie chart with a protractor and a compass and all of that. I am not going to require you to make one by hand. That would be really cruel and unusual punishment from me. So I'm not going to make you do that. I just want you to know what it is, see what it looks like, and I'm going to teach you how to make one on Excel. That's all I have for section 2.1. You should be able to do the homework with this now, and I will see you in the 2.2 video. Have a great one.